All right, let's start with this question. A biker and a bike have a combined mass of 80 kg and are traveling at a speed of 3 meters per second. If the same biker and bike travel twice as fast, all right, so here the information is given as twice as fast. Okay. So, meaning double the velocity, the kinetic energy will increase by a factor of 4. Actually, I've written the answer already. Now here you might think, okay, I have to increase double and then check. In fact, just look at the formula and then from there you can come to a conclusion. So if you have kinetic energy, original kinetic energy as half mv square, and let's assume that it doubles, the speed doubles. So how will the formula change? I'm just keeping the other quantities as it is. It becomes 2v the whole square, right? 2v, twice the velocity, and it is the whole square. So I will keep the rest of the quantities as it is half times m. This 2 square will become 4, right? And then you have v square. So now an additional factor of what do we have here? This 4. So if I take that out, 4 times, you'll notice that the rest of the factors remain constant. So half mv square. So which is the original kinetic energy, right? So you have a factor of 4 that is added, or that's in addition to the kinetic energy original. So if you double the speed or double the velocity of the object, the kinetic energy will increase by 4 times. So remember v square, right? V square. So if you have 3 times the velocity increased, so it will be 3v the whole square. So finally you will have 3 square, which is 9 times the kinetic energy will increase. The square of the velocity will be the increase in the kinetic energy. So keep this point in mind and then work out if any questions come in a similar situation. The next question, this one is based on this concept or the learning outcome where you need to apply the gravitational potential energy, and notice that it is the formula has mass times gravity times height. But this height is where you need to think from where to where, or is the height difference is how much, and you calculate that and apply it in the formula. Okay, so all these sections, the question might look very complicated, too much information details. No, it's a very simple concept. I'll just read it for you quickly. You can pause it, understand the question, try to solve, and then verify your answer. So you lift, meaning you're raising an object, bowling ball, from the storage rack and hold it up to your shoulder. The storage rack is 0.610 meters above the floor and your shoulder is 1.12 meters above the floor. Now both are labeled here. So that's a storage rack from which you are lifting the bowling ball. So you're taking it from this height. So to where are you raising it to? To your shoulder level. Okay. So the rack is at a height of 0.61 meters and your shoulder is a height of 1.12 meters from where? From the ground. So both distances are given from the ground. Now part A question is, when the bowling ball is at your shoulder, what is the ball earth system's gravitational potential energy relative to the floor? So they're asking you how much is the GPE stored in that bowling ball at that particular height from the ground level. So which height will you choose for this question? So the formula is the same, GPE equals m times g times h. So mass here is 7.3. Ignore that please. 7.3 times g is 9.8 times the height from the ground. See, read relative to the floor. So the entire height, which is 1.12. So you'll be getting roughly about 80 joules is the GPE stored with reference to the ground. Now part B, When the bowling ball is at your shoulder, what is the ball Earth's gravitational potential energy relative to the rack? So the rack is here at this point. So you need to consider the height from the rack to your shoulder. From the rack to your shoulder. How do you get that height? So that will be 1.12 minus 0.61, right? So for part B, you should consider this height. See, both are having the same formula, but you need to think about which height has to be substituted in the formula, right? So 7.3, the rest of the values remain the same. 9.8 is G times 1.12 minus 0.61. So you'll get roughly about 36 joules. So from here, that is from the rack to the shoulder, you have 36 joules of energy, gravitational potential energy stored on your shoulder. But from the ground to that particular height or to your shoulder, the energy stored is 80 joules. Right? Now, part C, how much work was done by gravity as you lifted the ball from the rack to the shoulder level? From the rack to the shoulder level, the work done, we know that it is stored as GPE. So for part C also, you will have the answer to be 36 joules. So work done by you in lifting an object through a vertical height will be stored in it as GPE. That is a work energy theorem again. Work done is equal to GP. I hope that's clear. Now this question is based on Hooke's law. Calculate the force exerted and also the energy stored, etc. Right? Let's see the question. A spring stretches by 18 centimeters. So stretches by 18 centimeter, it is already the extension given, which is x. Actually, Hooke's law is what? F equals negative kx. But for calculation, you can ignore the negative sign because it indicates the force, that is restoring force. So x is 18 centimeters. Potatoes weighing 56 newtons. So that's the cause for the stretching force. So the weight here, W itself, is equal to the force, right? So we also have the force given directly, 56 newtons. And what's the question asked? Spring constant. We know from the formula K is the spring constant. So you make that as the subject of the formula. So if you wish to calculate K, what will happen to X? X will come to the other side and it will be F over, sorry, K will be equal to F over X, right? You just change the subject of the formula and then direct substitution, 56. Yeah, before that, this is in Newton. Is this in standard unit centimeters? No, we convert this to meters. So divided by 100. So you get X equals 0.18 meters. So 0.18, I'll substitute it here. So which will give you 300, roughly about 310 Newton slash or Newton per meter. So the unit for K, you can look at from the formula. Force is Newton, X is in meters. So Newton per meter is the unit for K, which is otherwise the spring constant. Okay. So part A we have completed. Part B, elastic potential energy. For this, there are two formulae. You can use any of them. So EPE equals half kx squared or half into fx. So I use half kx squared here. Since I have k here, I have x here. Just direct substitution. Half times 310 times 0.18 square. Alright, which will be roughly about 5 joules. So that will be the elastic potential energy stored in the spring while it is stretched by 18 centimeters by this mass of potatoes, right? Okay, now this question, there is it's based on applying this equation. Now this is the time period. Capital T stands for time period of an oscillation, which is the time taken for one complete oscillation. Okay, it should be in seconds. That's the standard unit. Now, yeah, that's a very simple, straightforward substitution. easy, but see this question, they've given you the length 36.9, time period is already given, so you have capital T given, you have L given, but they ask you gravitational field G. Okay, so the challenge here is to make G the subject of the formula. All right, so the formula is 2 pi square root of L over G. So you need to find G. So that's testing your math skills. So what do we usually do to get rid of the square root? You square both sides, correct? You will be squaring both sides. So this square and the whole square you will be doing. So that will lead to t square equals 2 pi the whole square, right? And this square root and square will get cancelled, right? So you will just have L over G. So I repeat, t square 2 pi the whole square L over G. There is no square because square root and square will get cancelled. Now all you have to do is expand and then cross multiply and get G the subject of the formula. So let's do that. T square equals 2 square will be 4 pi square times L upon G. It's all multiplication, so I can take it as common. Now I want to make G the subject of the formula. So you have cross multiplication. So G will be equal to 4 pi square L upon T square. Okay. Now one more thing, this is in centimeters, so you have to convert this to meters. So length, first I will convert L equals 36.9 divided by 100, which is 0.369 meters. So substitute all these values here, you will get G. So 4 pi square times 0.369. You can use the pi value in your calculator as such, or 3.14 you can use. That's your choice, upon 1.22 square. I always tell my students, use brackets when you're having division to avoid error in the calculation, right? The final answer, I think it's roughly about 9.8 we should be getting. Okay, so here, as I said, the challenge is this part where you have to make G the subject of the formula, or they could also ask L as the subject of the formula. What's the length of the pendulum? So that you should be familiar with. If it is L, then it becomes, so let's do that. If they ask you to calculate L, how would this formula here change? So 4 pi squared L, when you do cross multiplication, will be equal to T square G. So L will be equal to T square G upon 4 pi squared. Right? So practice that. If in case such questions come, you can easily solve it.